This is Britt Caswell with another example video. In this video, I'll be covering example 2 from section 5-2 in the SavvasRealize Algebra 1 textbook. So in this example, we are focusing on graphing a piecewise-defined function. So the first thing that I do when I have a piecewise function is I start by graphing the individual pieces. Alright, I'm not as worried about the domain portion of it as making sure that those lines are on my graph. So for this blue one, I have y equals x plus 1. So my y-intercept is 1. And my slope, there's an imaginary 1 in front of the x, so my slope is 1. So this line would graph roughly like this. Isn't it nice having those, that one's terrible, those straight lines available to us. Y'all know I'm terrible at drawing straight lines. So there's our blue one. Now the other line that we have is right here, y equals negative 3 halves x plus 6, right? So our y-intercept is at 6, 4, 5, 6, and our slope is negative 3 halves, so I'm falling by 3 and running by 2. And so that's going to create a graph that looks roughly like this. Now, remember, we don't want our graphs to overlap, right? It still needs to be a function, so it still needs to pass the vertical line test. And these also have a restricted domain. So what we need to do is we need to cut down on these lines until it matches that domain. Alright, so now with the blue one, it says where x is less than or equal to 2. Alright, so if I'm thinking about my x-axis, I'm thinking about everything down this way. So anything after that 2, we do not need on the graph. So all this blue stuff that goes further on is unnecessary. Now for this red one, it says where x is greater than 2. So if I start at 2 and I go this way, this is where all of my domain is defined for the red one. So I don't need all this extra red stuff that's less than 2. So we're going to get rid of it here. And so now you have that nice little V shape going on. The only other thing that I'll point out here is, do you see how the blue one has the equal to? And I have a red dot there dominating it, the 2. I'm going to change that to a blue dot just so that it's perfectly clear that you're plugging into the blue function. In this case, it doesn't matter, right? If I plug in 2, I'm going to get the same value in either function. But that is important. Another important thing to note is that these domains, they don't cap on the left-hand side for the blue or the right-hand side for the red. So on my lines here, I'm finishing my lines with arrows to indicate that they're going on for forever in the direction that they have. So there's that piecewise function. Let's go ahead and let's try this next one. So on this one, it says over what part of the domain, okay, when it's talking about the part of the domain, right, we are talking about these inequalities. Is the function increasing or decreasing? Alright, so they have a graph here, and they just want us to state the inequalities where it's increasing or decreasing. Alright, now this red one, right, if I draw a little man on the left-hand side of the graph and he's walking uphill here, so this part is increasing. So I would say, I'm going to change this color to red. The graph is increasing over the interval x is less than 2, and I don't know how to put the less than or equal to when I type, so I'm just going to put that little line in there like that. So there we go. Now another way they might show that interval is they might say it goes from negative infinity, comma, to 2. And I use that square bracket because it can be equal to. And then I use the curved bracket because you can never reach negative infinity. So that's another way to say it. This is an interval notation, and so that's kind of nice. So now let's talk about blue. So again, if I'm looking at the blue, and I draw a little man on the left-hand side, and he's walking to the right-hand side, he's going downhill. Alright, so this blue dude, I'm going to try to write this sideways, is decreasing. Alright, so when I go to type, I would say the graph is decreasing over the interval x is greater than 2. And then if I wanted to write this in interval notation, alright, I would write it kind of like an ordered pair. It starts at 2, and then this graph goes on for forever to positive infinity. Right? Infinities get the curvy bracket. Now because it can't be equal to the 2, this 2 would also get the curved bracket like that. So there's the interval notation for that as well. Alright, so one last piece of this example. It just wants us to graph the function, so we're going to go ahead and practice that. So this one I'm calling blue. It's x minus 2, so y equals x minus 2. So I go down 2 on the y-axis, and with a slope of 1, this would graph like that. Alright. For this one, negative 2x plus 3. Alright, my y-intercept is 3. My slope is negative 2. So using my straight line tool, it would look like that. Now, this is where we need to use our domains here to tell us which parts of the lines we want. Alright, now the blue part is where x is less than or equal to 1. So here's where x is 1. So everywhere that way is going to be blue. So I can actually erase the blue here. Now it's important that we clearly define our endpoint. So because it can be equal to that 1, I'm going to put a solid dot for my endpoint. These y-intercept dots don't quite need to be so big, so I'm going to shrink them down a little so you guys don't think I'm talking about an endpoint there. Alright, now this graph does go for forever towards negative infinity, so I'm going to go ahead and put the arrow there at that endpoint as well. Alright, now the red one says x is greater than 1. So if I were to shade this, right, here's where x is 1. So everything to the right that way would be covered by the red. So I can go to where 1 is and erase all the rest of this. Now notice the red is not included at 1. So when I go to draw this endpoint, I'm going to put a hollow circle there so that you know it's not included with the red, but it is included with the blue. And then it continues on for forever, so I'm going to go ahead and put the arrow there. Alright, so it's very important that you guys note which endpoints you're using here. Alright? But there we have it. There's some piecewise defined functions. Until next time.